Section 4.3, Writing equations of parallel and perpendicular lines. So what we can see in our coordinate grid here is we have four lines. We have a red line and a blue line, a purple line, and a green line. So hopefully you can see these four different lines, and they seem to have some type of a relationship. This red line and this blue line are parallel lines. They're never going to intersect each other. The same thing is true for the green and the purple. They are also parallel to each other. Also of interest is the way that the purple line intersects the red and the blue, which is the same way that the green intersects the red and the blue. They actually intersect at right angles, 90-degree angles. That's where we call them perpendicular. So this graph shows us an example of two pairs of parallel lines, red and blue, and green and purple, and then also pairs of perpendicular lines, purple and red, purple and blue, green and blue, green and red. So let's take a look at the equations of these lines to figure out what the relationship might be here. First, looking at the red line, I can see that this has a y-intercept of 4, and it seems to have a slope where I'm going up 2 and right 3, so a rise over run of 2/3. And so my equation is y equals 2/3 x plus 4. Repeat this process for the blue line, and I see that I have a y-intercept of -3 and a rise, once again, of 2 and a run of 3. So it's actually a very similar relationship here. I have y equals 2/3 x minus 3. You'll notice that the slopes are both the same. That is not a coincidence, and we'll confirm that by looking at the purple and the green. And so the purple here, this line right up top, has the same y-intercept as the red line, also 4, and it has a rise that's down 3, that's -3, and a run right of 2. So instead of having 2 over 3, I actually have -3 over 2x plus 4. And finally, for the green line, my y-intercept is actually at the origin, so that's plus 0. I'm not even going to include that. But my rise is -3 and a run of right 2, so I have the exact same slope, y equals -3/2 x. But I do not have a y-intercept that I need to write. It would be plus 0, but we don't include that. So what I hope you're noticing here is that the parallel lines, the red and the blue, and the purple and the green, have the same slopes. That's one of the big keys here. And so that's our first big key. And the second thing is that the other combinations, the blue and the purple, the red and the green, the red and the purple, and the blue and the green, those are perpendicular. And if you'll notice, what's happened is my fraction has just gotten flipped upside down and been made negative. And that is also not a coincidence. What we do is we call that an opposite reciprocal. And so if the lines are perpendicular, their slopes are opposite reciprocals, meaning you take your original slope and you turn it on its head, turn it upside down, and then make it negative or positive depending on what it is. And from that, now we can actually write lots of equations of lines. So here are two different types of practice problems. Line L contains the points 3, 6, and -2, 4. Line J is parallel to line L and passes through 2, 6. What is the equation of line J? So since I know that these two lines are parallel, I know they have the same slope. To start by first finding the slope of line L by using the slope formula. And so that's just m equals y2, which is 6, minus y1, which is 4, over x2, which is 3, minus y1, which is -2. This is going to become 2 over 5. So my slope there is 2/5. Now what I have to do is I need to plug into point slope form with that slope and the point that's on my new line, my line J. So that's y minus y1, which is 6, equals m, which is 2/5, times x minus x1, which is 2. So now at this point I'm going to distribute the 2/5. I have y minus 6 equals 2/5 x minus 4/5. And now I'm going to add 6 to each side. Now when I do that, I might want to make it into a improper fraction. I might want to just have it as a mixed number. In this case, I think it's actually probably going to be easiest to just do 6 minus 4/5, which would be 5 1/5. And that's my equation right there. Y equals 2/5 x plus 5 1/5. Certainly you could have 26/5 if you'd rather do that, but that'll work out just the same. All right, next one, write the equation of the line perpendicular to 3x plus 4y equals 5 that contains the point 6, 2. So since the lines are perpendicular, their slopes are opposite reciprocals. So I first need to find the slope of this line, and probably the easiest way to do that is by putting it into slope-intercept form. So start by subtracting the 3x, that's 4y equals negative 3x plus 5. Then divide everything by 4, and I have y equals negative 3/4 x plus 5/4. So that's the same thing as my original line. Now I can tell that the slope of this line is negative 3/4 because that's in slope-intercept form. So the slope of the perpendicular line is a positive 4/3. That's the opposite reciprocal. And let me give myself a little bit of room here to work. So because the slope is positive 4/3, I can use my point, which is 6, 2, with my point slope form. That's y minus 2 equals 4/3 x minus 6. Distribute the 4/3, and that's going to be 4/3 x minus, that's a 3 right there. So 4 times 6 is 24, over 3 is 8. And adding 2 to each side, I get y equals 4/3 x minus 6. And there we go. That's the equation of the line that's perpendicular to 3x plus 4y equals 5, and it contains the point 6, 2. All right, so now time just for a quick summary. Parallel lines in the same plane do not intersect. They also have the same slopes. So we know what they look like, and now we know that their slopes are identical. Perpendicular lines intersect at right or 90-degree angles, and their slopes are opposite reciprocals. So if you have 2/3 becomes negative 3/2. Negative 7/5 becomes positive 5/7. If you have a whole number, like 4, just turn that into 1/4, and then just make it negative. That's what you can do there. All vertical lines are parallel to each other. All horizontal lines are parallel to each other. They have the same slopes, whether they're undefined or 0, if they're vertical or horizontal. And any vertical line is going to be perpendicular to any horizontal line, which I think makes sense. So there you go. Hope this section is clear.